Hello everyone. So in the previous class we were studying about maximum likelihood function and the term likelihood and probability both I have explained you in detail. What is the similarity? What is the difference? I've explained. I've also given the examples, storytelling based upon the concepts, and the one which you are seeing right now here, a simple example with a binomial distribution. This one also we have seen in the previous class. See, there is a likelihood function. Likelihood, it's a hypothesis which we give over a certain data and based upon our experiences. Okay. While probability is numerical calculation as a form of an outcome. Okay. So, in this particular example, there is a likelihood function, binomial distribution. Either I can say it's a probability function, either it is a likelihood function. Because what you are seeing here, that it is same. Okay, the binomial distribution. Okay, so likelihood function or probability function, but right now I need to calculate the maximum likelihood, so I'm considering it as likelihood function. Okay, so you have flipped coin 10 times. Success you are saying p, failure you are saying 1 minus p. Okay, 10 times you have flipped, therefore this is the binomial distribution formula. Then it has been told you have to take log of likelihood function. Okay, so in the next case I took log. Okay, log x log p plus 10 minus x log of 1 minus p. It's called as log likelihood function. And then I perform the differentiation. Okay, del L by del P. Okay, so this is what you got, del L by del P, and then you have to equate it to the zero to find the value of P. So maximum likelihood estimate, MLE, yeah, maximum likelihood function, or we are saying estimated values, is the parameters which we have to identify. We'll solve this equation, okay, and that will give you the parameters for which the function will be having the maximum value. So likelihood is something gonna happen. We are talking about an outcome. So over which set of data, or I would say that the parameters, what parameters will be contributing a lot for this likelihood to get succeed, maximum likelihood to get succeeded. I need to estimate what those parameters are. Okay, so you will be having a function, a likelihood function, take the log of it, differentiate it, equate it to zero, and find the value of parameter. That is MLE, maximum likelihood estimation. Okay, I have done the storytelling also. in the previous lecture. Okay, fine. So MLE is an approach used in many problems, probabilistic, especially for the different distribution of data, to perform imperative study, understand the concepts in advanced machine learning, deep learning. We do apply likelihood, maximum likelihood. Okay, so the difference between likelihood and probability, again and again, it has been coming because both are the similar terms. And in statistics and probability, this is what we have to understand carefully. So likelihood is a measure of the data observations up to which it can tell the results or a target variable for a particular data point. What I told in my explanation related to the likelihood is, according to my experience, I am doing observation, and after doing this observation, as per my experience, I will say a statement. So this statement is likelihood. You can quantify it in terms of a function that will be called as a likelihood function. So, as my previous example, that clouds have gathered, there is so much lightning, thunderstorm, wind is blowing. So, likely there will be a huge rainfall. Likely. So, this is likelihood that there will be a rainfall because you have done this observation that this situation has been created, so likely to happen, rain is going to happen, likely to happen. Okay, that's what a likelihood is. Okay, and probability describe the chance of happening or not happening of a certain event. Okay, probability describe happening or not happening of an event. Above I told likely to happen. In probability I am saying chance of an event to occur or not to occur. Here we have to give some numerical value to it. For example, you're talking about chance now. So chance can be like 95% chances that there will be a rainfall. So it is a probability. 5% chance that there is not a rainfall. So 5% is also a probability. Okay. So in probability, we are talking about chance. What is going to happen, what is not going to happen. In likelihood also, we are talking about something, what an outcome could be. We are also talking about the outcome in likelihood also. But we do have a hypothesis related to it. We can make a likelihood function also for it. That is the difference between likelihood and probability. Okay. Now, maximum likelihood estimation, I just discussed about it. So the term maximum likelihood represent that we are maximizing the likelihood function. On what parameters, on what value this function will give the maximum value. That's what we are doing. It's called as maximization of the likelihood function. So you are having a function, you took a log of it, you perform the differentiation of it, you equate it to the zero, you find the value of p. Okay, so in reference to the model, how this thing can be explained. Suppose we have a classification data in which the independent column is the mark of the student that they achieved in a particular exam, and the target or the dependent column is categorical. Yes and no. Okay, so marks and the campus placement. Okay, how much marks student achieved and whether the student was campus placed or not. Okay, so this is data set given to us. This is the data. Now, if we try to solve this problem with the help of maximum likelihood estimation, the function will first calculate the probability of every data point according to very suitable condition for the target variable. Next, we will plot these data points in two-dimensional plots. Try to find the best line that will divide the between yes and no. So you in what a classification model do? What we perform in a classification, we have to make a line that can separate. We have to make a line that can separate the classes. That's what we have to do. Okay. So like this. This is class A. This is class B. Right now we are having classification problem only. So yes and no. Okay. So what it is saying, if we try to solve the problem with the help of MLE, the function, we have to create a function, we have to write a function that will calculate the probability of every data point. What kind of probability it will calculate? The probability will be whether this point belongs to yes or no, according to the target variable. है ना? The target is yes or no. You have to calculate the probability that whether this point belongs to yes or no. In the next step, you have to plot these data points, whether they fall in a region of yes, whether they fall in a region of no, and try to find the line that will divide it in a best way. So this best fit line is achieved, that is used to classify the data points. Okay, and I made it, and here also they did made. Okay, let us suppose this is yes and this is no. Okay, so the maximum likelihood estimate is the base of some machine learning and deep learning approaches used for classification problem. Logistic regression, one of the algorithm that we do use to perform the classification. Okay, and it uses the best fit line. So best fit line, a line which divides the two data points in a best way. So there should not be any misclassification. This is maximum likelihood estimation, MLE. That's what it is saying, MLE. Okay. So identify a line or a decision boundary. We also called it as a decision boundary. Okay. So identify that thing that can divide your data into the two classes in a best way. That is maximum likelihood estimation. Okay. So what does it say again? In the above image, all the data observations are plotted in 2D. X represents the independent variable or the training data, Y represents the target variable. The line is separating both the observations, positive and negative, yes or no, whatever you want to say, you can. So, according to the algorithm, the observations that fall above the line are considered to be yes, below the line are considered to be no, or positive or negative, whatever you want to say, you can. Okay, so this is what a machine learning algorithm do. Okay, you are available with the data points. Okay, you are applying probability, and probability is a function. It is likelihood function. Don't just think, okay, applying probability, it's a likelihood function. So logistic regression is a logistic function, that I will teach you ahead. ओके, इट इज अ लॉजिट फंक्शन, लॉजिस्टिक फंक्शन बोलते हैं उसको. तो आप एक फंक्शन में यू विल पुट सम वैल्यू इन अ फंक्शन, that will be a probability function, because probability and likelihood are same thing. Okay, so you are going to put a value in a function, you are going to get a result. You'll get some result, and that result will be like, okay, your point belongs to which region. After putting that data point into the function, you are getting an outcome, and that outcome is telling you to which class a data point belongs. So class A or class B, या yes या no या पॉजिटिव या नेगेटिव बोल रहा हो. तो इसी फंक्शन को वो मैक्सिमम लाइक्लीहुड फंक्शन बोल रहा है ना. एक काम कर लो भैया, लॉग वॉग ले लो. That's not been told here. So we are having logit function or logistic function. That is an algorithm also called as a logistic regression algorithm used for classification. Okay, so we can take it, we can take the log, we can differentiate it, equate to 0, find the value of p, find the value of p. What are the parameters where my function is going to have a maximum likelihood? That's all also we can do. Right here, not too much has been told, just only told that there is a function, you are going to put a value inside it, take the outcomes, and find a best suitable line. This is the best suitable line, which is dividing class A with class B. This is what you have to estimate. ये लाइन को एस्टिमेट करना है आपको कि क्या होगी, what this line will be. Then you can have a best classification. Okay, fine. ठीक है. I'm having few more numericals to understand likelihood. Okay. Suppose you have a bag of coin. Okay. And you are interested in estimating the probability of getting heads when you flip the coin. Okay. Let's denote the probability of getting heads is p. So the tail is 1 minus p. And we flipped the coin 5 times. And these are the observations: head, tail, head, head, tail. So the likelihood function we can make here is LP. And it is given as LP is given as probability of head. Okay, ये देखो head आया था ना पहले. Probability of head multiply by probability of tail multiply by probability of head multiply by probability of head multiply by probability of tail. This is likelihood function. Okay. So the probability of head is p, probability of tail is 1 minus p. Substitute here. So p 1 minus p, p, p 1 minus p. ये आपका likelihood function बन गया. नाउ टू फाइंड अ मैक्सिमम, ये तो लाइक्लीहुड फंक्शन है. मैक्सिमम निकालना तो भाई लॉग लो, डिफरेंशिएट करो, लेकिन इन्होंने लॉग लिया नहीं, यहाँ पर डायरेक्ट डिफरेंशिएट मारना. Either you can take a log. Okay, log likelihood, that's also you can do. और नहीं तो to find the maximum likelihood you have to differentiate it with respect to p, with respect to probability. तो डेरिवेटिव ले लो, उसको जीरो से इक्वेट कर देना. सो दिस इज व्हाट दे डिड, dl by dp ये कर दिया उन्होंने, and equated to zero, and they can find the value of p. Okay, so whatever be the value of p is the correct answer, means for maximum likelihood वो मिल जाएगा आपको. Okay, so this is how we calculate maximum likelihood estimate. I do have few more examples and similar. Imagine you have cricket interest, you are enthusiastic, so you are interested in estimating the probability of batsman hitting a boundary, 4 runs in a particular match. You collect data of 10 match and this is what you got. Boundary, no boundary, boundary, no boundary, and dot dot dot. There are many more things. वो कट गया अभी यहाँ पे. So probability of boundary is p, not is 1 minus p. So you have to make a likelihood function. Then clear हो गई भाई बात. Boundary per p, not boundary per 1 minus p. Then boundary, then not boundary, then boundary, then no boundary, then boundary, boundary, no boundary, no boundary. This is your likelihood function. Take the differentiation, equate it to 0. That will be your maximum likelihood estimation. That's it. Now the things are becoming very easy. Okay. So likelihood, it can be expressed like this way. अच्छा, वो आपने जो बेस थ्योरम पढ़ा ना भाई, वो भी यही है. Bayes theorem also comes under this category only. Okay, in Bayes theorem you took conditional probability. Okay, like this: P A by B is equal to P B by A into P A upon P B. This is Bayes theorem. This is your likelihood. तो likelihood है यहाँ पे. And this is posterior probability. This is prior probability and this is the evidence. तो likelihood आ गया ना, ये रहा likelihood. Okay, fine. So it can be written in this way. It's telling like this way. Okay, and we are finding the best parameters in MLE, maximum likelihood estimate. We are finding the best suitable parameters to solve this function. Okay, so yeah, I think that's all for this likelihood thing. Okay, I don't have much more to tell. And either you can take this, for example, you can take a function. They have taken a function. This is your normal equation. Okay, you can say that this is a likelihood function. Okay, and you can differentiate it with respect to. Okay, here they have performed the differentiation. They took a log and they performed the differentiation of it. Okay, fine. With respect to nu, that is the mean. They took the differentiation and then they have equated to 0 and find what is the value of nu. Okay, nu, and then they have differentiated it with respect to standard deviation and then find what is the value of standard deviation. Okay, so this kind of math now you can do. Okay, fine. Rest is not so important for you to understand because it's okay. So you will be getting a function, a likelihood function, and you have to differentiate it with respect to parameters so that to get the best parameters. If in your function, for example, the questions which I have shown you, that was having only p as a parameter, p1 minus p1 minus p. So it was having only p as parameters. So you differentiated with respect to p only. For example, just right now I have shown you a normal equation, and in normal equation, if you say that the likelihood function, it is having nu and sigma. Two things are there because the formula says like this: square root 1 upon square root of 2 pi sigma e की power x minus nu का square upon 2 sigma square. So here nu and sigma, these two are the parameters. So it performed the differentiation del L by del nu equal to 0, and it performed the differentiation del L by del sigma equal to 0 to find the value of nu and sigma. Maximum. Okay, maximum likelihood estimate, parameter estimate. What should be the best parameters related to it? Okay, so that's what it found. Okay, this is how you can solve maximum likelihood function. So, if you have been asked what is the difference between likelihood and probability, you should be now able to give the answer. Both are confusing terms, they are correlated because both will talk about outcome. Okay, so in an interview, you have to say probability and likelihood are interrelated. Listen to me carefully. This is what the answer you have to give. Probability and likelihood are interrelated. They confuse because both tell about the outcome. However, there is a difference. We will tell you what is the difference. Probability measure the occurrence of an event likely to happen. However, probability quantify the likelihood. It gives a numerical answer for it. So, in case of likelihood, we will say rainfall is going to occur, likely to occur. In probability, we will say there is a 95% chance that rainfall is going to occur. So, it is a quantification probability. In likelihood, we do have a likelihood function. Okay, just right now I shown you some examples in their likelihood functions you have seen. Here we don't have any like, okay, we do calculate the probabilistic function, that is random variable or something like that. So however, we give a probability result in case of the probability between 0 to 1. What is the chance? है ना, range between 0 to 1. It can take any positive value including value greater than 1. ये likelihood का कोई range, it's not like that 0 to 1. It can take any positive value. In fact, more than 1 also. Okay, so if you toss a coin, likelihood is to talk about whether you are going to get head. How likely you can get a head in tossing of a coin. Probability 50%. Likelihood will not tell that you toss a coin and the chances getting a head is 50%. nahi. Likelihood only talk about obtaining a head, likely to obtain a head. That's what likelihood tell. But probability will tell 50% chance. Okay, that is the best example, best difference example between likelihood and probability. You can see that the likelihood of obtaining head on an observed data is defined as likelihood. However, probability is 50%. In linear regression, the likelihood is observed data given on a regression coefficients on a regression line. Okay, that means likelihood of observed data given the regression coefficients. I will tell you what the regression is, what this coefficients is when I will teaching the linear regression. Here, the probability of person being taller than 6 feet is point. Again, it will tell about the value. Likelihood will not tell about the value. It's a hypothesis or it's a statement likely to happen. That is the difference. Okay, fine. So I hope you understood what is the difference between probability and the likelihood. I have repeated so many times, so many examples I have given. Okay, and in the lectures and with these examples, you will prepare yourself for your interviews, and you should be able to tell. Okay, fine. So either you can read this content also. I am available. I will share with you, so you can read it. The same things are written. What I taught, same things are written. MLE also, maximum likelihood estimation. Everything is just mentioned here. Applications of probability. Okay, misconceptions are there also, so you can study. Okay, so that's about probability and the likelihood. Okay, now next important concept, that's what we have to study, is information theory. Okay, let's study information theory. That is the next topic after probability, information theory. Okay, so first of all, okay, this is a new topic, very interesting topic. It comes under probability, and we have to focus upon this also. Information. What do you mean by information? We'll say, sir, data processing is information. Okay. So we want to learn about information in this topic. That's what it's called as information theory. And information is the heart of information theory. Okay. We will be performing encoding. I hope you have studied one subject that's present in our engineering, that is related to network also, and data transmission, okay, data communication. So such kind of subjects are there where you do encode the information in 1001, something like that. This is information, and there will be transmission of information from source to destination. That's what we do. Okay, so we do perform the encoding of the information. Okay, how I'm going to use it in machine learning and data science, let's see. Think about the following exercise. A deck of cards belongs to friend of yours, ours. They will deal out some cards, shuffle the deck, and then make some generalization about the cards. We shall make an effort to evaluate each statement informational value. Like, they first turn over a card and say, I see a card. This gives an absolute no information. As we already knew that this is to be a case, we anticipate the information will be zero. Now, if they say, here is three of spades, this is an information. There are 52 equally possible outcomes. Our friend was able to reveal. What it is telling? It's telling that, listen to me here, information. It told that you are having 52 cards, okay, and in this 52 cards, you shuffled it, okay, and a statement is given over a card. For example, if it has been picked, I see a card, I see a card. What card? Don't know. Okay, let me share my entire screen. So you were from that long time just sitting idle? Yes, I have covered so many other documents. You have to at least ping me now. Okay, so it's your fault. I can't do anything. If you don't ping me that you are unable to see the screen, then it's your fault, not my fault. Because while teaching now, it may happen that I am in a rhythm and I forgot to share the entire screen. I can't share entire screen in the opening. No, it is not possible. It will not come in the recording. Okay, it got freeze after started. Else you were seeing. Yes, Mr. Abhay. Else it was seen. Yes. Okay. Now is it visible? Now can you see a fresh screen where information is written? Okay. So if any time you find that you are unable to see, and ping me at the same, okay, same moment. Okay. So I hope now you can see that information has been mentioned here. Hmm. The story mentioned was 52 cards shuffled and a card is picked, and I see a card is told. Here, zero information is there because I don't know what card it is. Whether it is a spade, whether it is a king, queen, whatever. So at least I should know na, that the card which you have picked, what kind of card it is. Then only I can say that some information has been conveyed. Information is a very important thing, very, very important. Let me give you one more statement. I will not attend class tomorrow. Okay, here a statement is conveyed. I will not attend class tomorrow. But why? Why you will not attend class tomorrow? This is not mentioned. Okay, we can say that there is some information, but not complete information. Not complete. There is some information that you will not attend class tomorrow, but you haven't mentioned the reason. Okay, if you say that I will not attend a class tomorrow because I am sick, I need to meet the doctor. I need to see the doctor. Now this information is complete because I know the reason why you are not attending the classes. So this is the information. This is info. If you don't speak completely, then okay, I don't know what the reason is why you are not attending. So this is not the information. Same thing in the cards example also. I see card. What kind of card you are seeing? You have 52 cards. You shuffle the card. You picked a card. I see card. What kind of card it is? किंग है, क्वीन है, जोकर है, क्या है, क्या वो, ये बताओ तो सही। क्या है तो मेरे को पता चले, इन्फॉर्मेशन आई विल गेट। बता नहीं रहा हो, अगर मुझे कार्ड दिख रहा तो कार्ड दिख कौन सा रहा? ओके, इन्फॉर्मेशन, यू हैव टू राइट इट कंप्लीटली, देन देयर विल बी सम इन्फॉर्मेशन। ओके, नाउ अभी तो खेल शुरू हुआ, देखो। हम्म, इधर आते हैं। तो वी डू हैव अ शेनॉन, दिस पर्सन। Now, everything I always repeat many of the times, whatever you see, whatever you do, can you quantify it? Can you convert it into maths? Okay, can you convert it into maths? Are you a logical person? Do you understand a problem? If you can, and if you convert it into maths, then only you are a winner. Because the persons whose concepts we are studying, they did converted a problem into maths equation. That's what Shannon did. Shannon, on the basis of information, okay, you have given a statement. Na? Shannon gave a formula that if you are giving a statement, how much amount of information is gained from it if any event is occurred. If any event is occurred, how much amount of information you got from it. And its formula is minus log p. This is the formula. How much amount of information gained when an event occurred. For example, if a coin show head all the time, the events are predictable. That means there is nothing new, so no information. जब आपको पता ही है कि ये होगा, तो कोई जानकारी थोड़ी ना मिल जाएगी वहां से. You will never get an information if you already know that what's going to happen. There is not anything new. But if there is a chance in an event. That means if the coin is not biased, it is unbiased. So the probability distribution is uniform and most unpredictable. If the things are unpredictable, then there you require information. क्या होगा, मेरे को जानकारी तो दो, तो मेरे को पता चले. जहां जहां जो पता है, तो वहां कोई जानकारी की जरूरत ही नहीं है. If the things are unpredictable, if you don't know what can happen, there you need information. Okay. So if the coin is unbiased, it is a fair coin, and if you toss it, head can come, tail can also come. This is unpredictable. 50% chances is of head, 50% chances is of tail. Unpredictable है, कुछ भी आ सकता है. So the information will be at this particular log of px. P is the probability. So for head, the probability is 1 by 2. For tail, probability is 1 by 2. So minus log 1 by 2 minus log 1 by 2. Actually, I need to consider all the events, all the possible events. Summation लगाओगे भाई, इस फॉर्मूले में summation लगेगा. Okay, okay, let me show you here. Summation of minus log of px. ये है वो. That means consider all the events. So log of the probability, and whatever be the result you are going to get. For example, minus log 1 by 2 minus log 1 by 2. Okay, for head and for tail. So minus 2 log of 1 by 2. Okay, minus 2 log of 1 by 2. So if I take minus 2 log of, okay, 50% है ना, हाँ 50 ये तो था. हाँ, so 2 की पावर -1. एंड इफ आई से ये माइनस इधर कर दो, तो 2 log 2. ओके, 2 log 2. ओके, दैट इज द आंसर. ओके, एंड व्हाट इट इज सेइंग बोला यहाँ पर. हाँ, इन कंप्यूटर साइंस द इंफॉर्मेशन can be represented in bits format. And if you take log to the base 2, for example, so for flipping a coin is log 2 1 by 2, 1 bit. That means अब वो हेड और टेल को जो है 50% चांसेस प्रोबेबिलिटी के तौर पे बोल रहा है. फॉर एग्जाम्पल, इट्स बीन टोल्ड अबाउट अ हेड. व्हाट इज द चांस दैट हेड विल अपीयर? व्हाट इज द इंफॉर्मेशन? दैट head came while tossing a coin. How much information I got? So -1 minus log of 1 by 2. Okay, so log of minus है 2 की power -1. -1 will come in front, so it is log 2, and here it is taking log to the base 2. So log 2 to the base 2 is equal to 1. So 1 bit information. 1 bit information. So tossing of a coin resulting into head requires 1 bit to store it. To store this thing. इस इंफॉर्मेशन को, इस जानकारी को स्टोर करने के लिए मुझे 1 बिट की आवश्यकता है. ये कहना चाह रहा है. To store this information, I require 1 bit in a memory. This is how I quantified the information. Okay, how much bits are required? That is encoding. Okay, so how much bits are required to store information? Formula log px minus log px. For all the events, take summation. That's what I did here. 2 log 2 आया था ना for all the events. So if I take 2 log to the base 2, this will be 1, so 2. So 2 bits are required. ऐसा हो जाएगा. Okay, very important concept. Fine. So random variable you very well know. Just in probability only we have finished random variable. A random variable is a variable that is defined over a function, and it can possess any value in the entire domain of that function. Okay, so rolling of a dice, total number of heads after flipping coin 20 times, these values are held by the random numbers, random variable. Okay, so information theory is a branch of maths, applied maths, and electrical engineering also, that is used to quantify the information, because information flows from one place to another place. I need to quantify it. I need to measure and analyze how much amount of information a signal or a data or a message possess. कितनी जानकारी है उसमें एक सिग्नल में, because I am sending something. From here also we are taking a we are having a live class and speaking something. You are getting my voice. How much information is conveyed? Okay, so everything will be converted into signals. So that will be like 0 1 0 1 0 1, like this signals, digital signal. ओके, सो ये पूरी एनकोडिंग होगी. मेरी इंफॉर्मेशन जो मैं बातें कह रहा हूँ वो पूरी एनकोड होगी 0 1 0 1 0 इस फॉर्मेट में. ओके, so according to the Shannon, it give a formula minus log of px. Okay, and after this, after Shannon formula, another very important concept came into the picture: entropy. Entropy again, degree of randomness, uncertainty in a data. And why we are learning, why we are studying all these things? Because our data, our outcome is uncertain only. Why we are learning this concept of information? Our data is uncertain only. Your and how? Why? Because okay, you just take an example. Na, you toss a coin, head may come or tail may come. कुछ भी आ सकता, uncertain है ना. ओके, हमारे मशीन लर्निंग जो मॉडल है, एमएल मॉडल्स हैं, दे आर स्टैटिस्टिकल मॉडल्स, वो लाइकलीहुड वाले. अभी बोला ना. ओके, यू कैन सी our machine learning models which we are going to see ahead, they are statistical models. ML models, statistical models. Okay, likelihood, they are likelihood function. What is going to happen? Obviously probability is involved here. Okay, and the probability is involved here. What is the formula which the Shannon gave? Minus log of px. Probability is involved here. What is entropy? Degree of randomness. So random बोले तो फिर अगेन प्रोबेबिलिटी इज इन्वॉल्व है, तो भाई प्रोबेबिलिटी पीछा नहीं छोड़ेगी तुम्हारा, ये मत सोच लेना कि बच जाओगे यहाँ. ये तो स्टैटिस्टिक्स एंड प्रोबेबिलिटी को खा जाएगी. ठीक है, अनलेस एंड अनटिल यू डोंट हैव अ स्ट्रॉन्ग मैथमेटिकल फाउंडेशंस, लीनियर अलजेब्रा, स्टैटिस्टिक्स, प्रोबेबिलिटी, कैलकुलस, इससे 80% तक बिलोंग करते हैं ये. हाँ नहीं, वो हर जगह लगी प्रोबेबिलिटी, तो बचोगे नहीं आप. सो एंट्रोपी, degree of randomness, uncertainty in the data, and our model are going to give a certain prediction, और वो भी uncertain ही होगा. For example, just अभी classification we did talked. So classification, it may give 0, it may give 1. ये हो गया ना uncertainty. So there is uncertainty. Our models are also probability statistical based models, which do have the probability. Okay. So because of the uncertainty, there is a term which came as entropy. और अपने डेटा में यही तो है, अनसर्टेनिटी. डेटा अनसर्टेन है. आपके या मेरे भरोसे नहीं बैठा डेटा. डेटा इज अनसर्टेन, आउटकम प्रिडिक्शन अनसर्टेन. देयर इज सो मच अनसर्टेनिटी इन लाइफ ऑल्सो. एवरीवेयर देयर इज अनसर्टेनिटी. आप बोलो कि सर सब कुछ सर्टन है. इफ यू से दैट एवरीथिंग इज सर्टन, हाउ आई कांट बिलीव यू. हो ही नहीं सकता. कल क्या होगा ये पता है क्या आपको? ठीक है, अनसर्टेनिटी तो हमेशा बनी हुई है भविष्य को लेकर. सीधी सी बात है. और एआई में करता क्या हूं मैं? एआई में क्या कर रहे हैं? फ्यूचर प्रिडिक्शन कर रहे हो ना भाई. प्रिडिक्शन ही करते हो ना. ठीक है. तो अनसर्टेनिटी हुई कि नहीं हुई, वो तो नाम से समझ में आ रहा है. आप कॉन्सेप्ट को कनेक्ट करने की कोशिश करो. ट्राई टू कनेक्ट द डॉट्स. अनसर्टेनिटी तो है. अनसर्टेनिटी तो प्रोबेबिलिटी है. Probability, information theory, and then you're talking about the entropy. Entropy, the formula is minus px log of px. This is entropy. Minus px log of px. So Shannon formula was minus log of px. But entropy formula is minus px log of px. Summation you have to include. Summation include करना है ना. All the possible outcomes I need to consider. For example, if I do talk about tossing of a coin, okay, tossing of a coin. So probability of head is also 1 by 2. Probability of tail is also 1 by 2. So minus summation of probability of head into log of probability of head. Summation हटा दो यार अब यहाँ से. Okay. So minus 1 by 2 log of 1 by 2 minus again 1 by 2. That is the probability of tail. Log of probability of tail. Okay, so minus 1 by 2 log of 1 by 2 minus 1 by 2 log of 1 by 2, that will be 2 into 1 by 2 log of 1 by 2 minus लगा दो. 2 से 2 get cancelled. So the answer is minus log of 1 by 2. ये आंसर है. Minus log of 1 by 2. If this is log to the base 2, तो आप जानते ही हो, minus log to the base 2 की power minus 1. Minus 1 you can take in front. So log 2, 2, 1. Okay, 1 is the answer. That means entropy of flipping of a coin is 1 bit. ओके. पूरा कैलकुलेशन करके बता दे. इसने तो लाइन लिखी थी, मैंने पूरा कैलकुलेट कर दिया आपको. 1 कहां से आया? ओके, 1. एंट्रोपी ऑफ फ्लिपिंग ऑफ अ कॉइन इज 1. ओके, फाइन. सो that's related to fair coin actually, where head and tail may appear. If you consider an unfair coin, that means one sided is heavier than the another, then more likely to land on that particular side. In this scenario, अनसर्टेनिटी कहाँ बची भाई? आपको तो पता ही है ना आउटकम क्या आएगा. अनसर्टेनिटी बची कहाँ? सो एंट्रोपी इज लोअर when the outcome is more predictable. When the outcome is predictable, you very well know that this may appear, so entropy is less. But when there is so much randomness, when there is so much uncertainty in the data, uncertainty in the outcome, then entropy increase. Entropy increase when uncertainty increase. So entropy is a way of quantifying the uncertainty in the data. That is a key concept of information theory. भाई ये main concept है information theory का, entropy. अभी आएगा आगे एंट्रोपी, क्रॉस एंट्रोपी, जॉइंट एंट्रोपी, मेनी थिंग्स विल अपीयर. सब में ये लगेगा लॉग पी और ये करके खेल करेंगे. Okay, so information theory, concepts like entropy, it provides a mathematical framework for understanding and quantifying information. So you need to quantify, apply entropy. Okay. So it measure the amount of uncertainty or surprise in a random variable. You do a random experiment, na? You are tossing a coin, na? So random variable may get head or tail. Entropy. You have to apply to measure the uncertainty in the data. Got it? There are many more things to say that I will be talking ahead. I hope you enjoyed today's lecture.